All right. Spending Valentine's alone tonight. Yep. Nope. My wife and kids left me. They did. Yeah, they went to Fargo for a hockey tournament. Sad they won't be back till Sunday. So, nope. No party at my house. 8-5, day 2, rational inequalities, blah, 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 learning targets. We're going to solve word problems today and rational inequalities. Let's jump right in here. So when we've solved inequalities all year, what have we done? Yeah, we've kind of treated it as an equal sign. Good. So we got some listeners in here. And we've also used what? When you divide by a negative, you flip it. Good. There's another thing. We also have used these number lines, right, to represent all the numbers in our solution. Okay. So there were special little dots or critical values or boundaries, we called them, on our number line. How do we get those points? And Aaron, another shout out, said that we treat it like an equation. Good. So we treat it like an equation, and that will give us the little boundary point on there. And sometimes we color it in, and sometimes we don't. Do we color it in this case? Yeah, because of this little greater than or equal to sign, right? So let's solve it like an equation, just like we did yesterday. So we got x over x minus 3 is equal to, I'm going to make it 4 over 1. Since it's a ratio or a fraction, equal fraction, I'm going to use the cross products property, right? Some of you guys say cross multiply. Some of you say precious heart method. So you can use cross products. So we can go 4 times x minus 3. If you were going to get a common denominator, you would be doing the same thing as cross products in this case anyways. You would multiply this one by x minus 3, and you would multiply this one by 1. That's silly. And then you'd get, right? So you'd be doing the same thing. So 4 times x minus 3 equals x times 1. Solve this up, we get 4x minus 12 equals x. So we get 3x equals 12, and we get x equals 4. You agree? That was kind of fast, but yep, that's right. So now 4 is going to be one of our boundary points, critical values, the dots on a number line. I'm going to color it in. Where's the other boundary going to come from now? There's going to be another boundary. Okay. There's one number for the variable x that is not allowed because, see, we have variables in our denominator. 3, good. Yeah, 3 is not allowed. So because x cannot equal 3, this little angel baby's carrying around x cannot equal 3. So he's like, x cannot equal 3, see? X cannot equal 3, so that's going to be a boundary point too. So we're going to put that on our number line. And are we going to color that in or no? Yeah, so a little tricky here, but x cannot equal 3, so we're not going to color that boundary in. So this is going to have one that's not colored in and one that is. Okay. So now we have to do our test points and see if it's going to be all the numbers in between or on the outside. So put 0 in there. We get 0 over negative 3. 0 over negative 3 is 0, and that's not greater than 4, so it's false. So it's falso. Okay. What about 5? We put a 5 in there. 5 over 2, that's going to be 2.5. That's not greater than 4. That's also false. So it should be true in between. I'm just going to double check here, make sure. So I'm going to put a 3.5 in there. So I get 3.5 in, and on the bottom I get a 0.5. And if I take 3.5 divided by 0.5, that's the same as timesing by 2. So 7 is greater than 4, so it's true. Ta-da! So it's going to be true between all numbers between 3 and 4. So you write your solution like this. X is greater than 3, cannot include that, and less than or equal to 4. Okay. All right, good. Any questions? All right, let's get. Okay, your turn. Give it a shot. So maybe you can draw your number line first, maybe. Well, that's not a number line. Okay, there's one number that's going to be a boundary point. So what are going to be your boundaries or your critical values? Well, one of them is going to be what? Not equals 0. So 0 is going to be a boundary, and then you got to solve it up to find the other one. I'll give you a little pause and a head start here to solve it. Okay, so we're back from a whole bunch of whining, and we found that 0 and 4/7 were the boundary points, and 4/7 could be colored in, I believe, right? Yep. So now where is the solution for that going to be? Well, if I go to 1 and I put a 1 in there, I'm going to get 4 over 1, and that's not greater than 6. So 1 is false. So false to the right. If I put a -1 in, I'm going to get 5 over -1 is -5, and that's not greater than or equal to 6, so that's false over here too. So false, false must be true in the middle. What's a number between 0 and 4/7? A half. Yeah, a half, that's 3.57. So I put a half in there just to double check here. I put a half in there, I get 3.5 divided by 0.5, and that's 7, and that's going to be greater than 6, so that's going to be true. So it's all the numbers in between there again. So any number x greater than 0, less than or equal to 4/7. Ta-da-da-da, 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 ta-da-da-da. All right, you ready to have some real fun now? These two girls up in the front, they both used to work at Target. All right, here we go. Now off to the word problems. These are some of my favorite ones. Yep. No, I'm serious. I really like these. They're fun. They're challenging. So a lot of these are going to be based off of this. This formula, distance equals rate times time. You've seen that before. And also you can rearrange that for R. You could say rate equals distance over time. Or you could say time equals distance over rate. Right, and so we're going to use this formula in one of these different ways probably for most of these problems. So in this case, on a river, a kayaker on a river is, we'll just draw a little river here, cruising down the river. Okay, the stream, the river flows this way, and here you are kayaking. So you're kayaking down the river. You're going to go fast. You're going to go faster this way than you are going up the stream because you're fighting the stream, right? If you're just going in a normal, if you're just going in like a normal lake that didn't have a current, you would be going how fast? It says in the problem, if you read it, 2 miles per hour as a, see up here, 2 miles on average speed based with no current in still water. Okay. So this is going to be 2 miles an hour plus the current. Woo! This one's going to be 2 miles an hour subtract the current. Oh gosh, it's so hard to get out of this stupid current. All right. So, and this is fun because this guy can get banged around all sorts of stuff. So we got to write an equation. That's the hard part. What is going to be equal? If we write an equation, something has to be equal. So let's read the problem. On a river, a kayaker travels 3 miles upstream and 3 miles downstream in a total of 5 hours. When I read this part, in a total of 5 hours, that's like, as a math student or math teacher, I'm thinking, okay, that's a big little snippet there. That's an important part. Total of 5 hours. To me, that's like, I'm thinking All right, total of 5 means I add stuff, and it equals 5, doesn't it? I'm going to put 5 over 1 because we're going to have fractions involved. All right, now what equals 5? Distance, rate, time, what does that represent? Time, good. So now I need an expression for time upstream and time downstream. And so time is represented by distance over rate. And so that's where the 3's come in. And the rate is going to be based on whether you're going up the stream or down the stream. So if I'm going up the stream, I'm going to be going slower by the current speed. And if I'm going down the stream, I'm going to be 2, holy cow, what happened there? 2 plus, it's glitching out. 2 plus the stream. Okay, now we have a rational equation to solve. So what is going to be my common denominator? 2 plus t, 2 minus c, and 1. C is the current. Good call. Good question, and we should define that. We should say C equals speed of current. Sometimes defining your variable helps you to write your equation first. So I probably should have done that earlier. And the last sentence usually gives away what you're looking for. Like, what is the average speed of the current? Okay, well, that's what we need to make our variable, because that's what we're trying to solve for. So let's get common denominators here. So I'm going to multiply this one by 2 plus c over 2 plus c. I'm going to multiply this one by 2 minus c over 2 minus c. And I'm going to multiply this one by both of those, which is going to be 4 minus c squared. I'm going to just multiply it out because I want to save space. Whoops, what? It's not that though, silly. Silly goose. All right. Okay, so 4 minus c squared. Multiply it all out. Okay, so at the top here, I'm going to have 6 plus 3c. I'm going to ignore my denominators because they're all going to be the same. Plus 6 minus 3c. And that equals 5 times 4 minus c squared is 20 minus 5c squared. Okay. On the left side, my plus c and minus c are going to eliminate, and the 6 and 6 make 12. And so after I manipulate this, I end up with 5c squared is equal to 20 minus 12, which is 8. Because I moved the 5 to the other side to make it positive, and then I subtracted 12 from 20 and got 8. And now I'm going to take the c squared, get it by itself. C squared equals 8/5. So the current is equal to the square root of 8/5. And then, because I'm actually solving a question that you want to make sense of, I put it in my calculator and I got 1.26 miles per hour approximately. Approximately 1.26 mph. Wow. So I do a problem like that. It's just a pretty excellent problem. And no one cares. No one cheers, no one applauds. No one, I mean, there's like, thank you. I'm just kidding. I'm just kidding. I don't like that. Told you about the time that the one student then started manipulating me when I started getting crabby. They started making the class cheer for me. It actually worked every time. Okay, last one. This one's a little different. Sam is shoveling a driveway in 3 hours by himself. This one's very appropriate for the weather lately. But so Sam shovels in 3 hours by himself and Zach shovels in 2 hours by himself. How long does it take them if they work together? 5 hours. No. No, that would be the opposite of common sense. It should take less than 2 hours, right? If they help each other. Unless if someone's like, unless they get together and they start screwing around and then they detract from their work, that might happen. Okay. So it helps to think of this one in terms of rate. So what is the rate that Sam shovels the driveway? Actually, you said X. Let's talk about X for a minute. That's a good question. What should X represent? Good. How long it will take them to shovel the driveway? That's what we want to know. So X is going to be the number of hours shoveled together. So the number of hours they shovel. Okay, so if they shovel for 1 hour, how much of the driveway is Sam going to get done? See, sometimes it helps to just throw values in there and start thinking about, like, because you're trying to make an equation or write an equation, but it's hard. So how do you do that? Well, sometimes you just put numbers in and figure it out that way. Like, what if they did one 1 hour? How much of the driveway would they get done? Would 1 hour work? Think about it. Sam would get 1/3 of the driveway done because it takes him 3 hours, right? Interesting. And then how much would Zach get done? Half of the driveway. Does 1/3 plus a half equal a full driveway? Dang, it'll be more than an hour. Wait, no, it doesn't. A half plus a third is not quite one full, but it's going to be, is it going to be 2 hours? Okay, so let's make an equation out of this. What we want to know, well, we're almost done. We're almost done here. Let's focus a little bit silly today. Sam's shoveling rate. That's what we need to know. Sam's shoveling rate. What is it? Per hour. Sam's shoveling rate per hour. 1/3. Yeah. So Sam shovels 1/3 DPH, driveways per hour, right? And Zach shovels 1/2 driveways per hour. Okay? So what we want to know is how much time. So if we go back and we think about the time is equal to, what was it again? It was like, actually, yeah, that might confuse. I'm not going to go there. Yeah, well, but this isn't really distance, rate, and time. So let's go back. How much of a driveway are they going to get done? So if I say, let's just say 1/3 is the rate times how many hours, right? That expression would represent how much of a driveway Sam gets done, plus the rate that Zach shovels, and we want that to equal a total of how many driveways? 1. So there's your equation, and we've been solving these by getting common denominators. So I'm going to write this as x over 3 plus x over 2 equals 1 over 1. Common denominator of 6, so 2 times 2 there, 3 times 3 there, or 3 over 3, and 6 over 6 there. So you end up with 2x plus 3x equals 6. 5x equals 6, and x equals 6/5 of an hour. So that is 1 hour and 1/5 of an hour. 1/5 of an hour is 12 minutes. Huh? Good estimating skills. Yep. So that one was a little different, but yep. That's where we're going to wrap it up. I'm going to give you guys a chance to start cranking out the equations. The hard part is writing the equations. So happy Valentine's Day. Happy Valentine's Day.